Using your own knowledge, describe the patterns shown in the graph above and suggest some reasons for these trends. This is quite a difficult 6 marker because it requires you to look really carefully at the graph and use that along with your own knowledge that you know from your revision, the specification, to come up with reasons for why the graph is the way it is. So the first thing you should do whenever you see this sort of question is explicitly look and state the overall general pattern. And we can see that the general pattern here is that there's an overall gradual increase in CO2 concentration from 2010 to 2020. You can get extra marks if you quote specific figures, so you could say something like it increases from 386 parts per million in 2010 to around 410 parts per million in 2020. You then need to use your own knowledge to come up with reasons for that trend, and any sensible suggestion will get you the mark. The key things to think about are increased combustion of fossil fuels. So we're talking coal, oil, and gas, burning those for electricity mainly, and that will release a lot of CO2. We've got increased deforestation, so that's the cutting down of trees, which means that there's less photosynthesis absorbing CO2 from the atmosphere, and that's to increase space, for example. The trees can also then be burnt, so again, combustion of trees, that will release even more CO2 into the atmosphere. You can really relate both of those comments to an increased human population. We know the human population has increased between 2010 and 2020, and this will lead to an increased demand for resources, so we're talking things like food and electricity. So they'll need more space for people to live, for example, that's urbanisation, increased urban areas, so bigger towns and cities. So we're going to have more construction, we're going to have an increased demand for electricity, an increased demand for different facilities and services. Food, again, we need to ensure food security, so we're going to need more land for farming, for example. You can also link this to ideas of westernization, so countries which previously had an extremely different culture to the Western world, so we're talking places like America, France, Germany, Britain. Countries so previously had very different cultures, sort of like China, India, they're becoming increasingly westernized and they're trying to live an increasingly Western lifestyle, which is increasing the amount of strain on food, for example, and again, services and facilities that require a lot of resources such as electricity. Also, a rise of intensive farming, which leads to more and more CO2 being released into the atmosphere, and we need that because we need more food to feed a growing population. A little thing that you might not know is that warmer oceans release more CO2. So of course we know that increased carbon dioxide concentration leads to global warming. Global warming means that the oceans will be warmer. And warm oceans release CO2 from the sea into the atmosphere, so it's making the situation even worse. Cooler oceans, however, will absorb more CO2, so it's kind of a positive feedback if you've heard of that before. So one thing makes another thing worse, so we're getting increased CO2 makes the world warmer, global warming makes the oceans warmer, which means that the oceans release more CO2. The second part of this question, and perhaps the harder thing to look at, is then to notice, well, actually, there's some fluctuation there. Fluctuation is when things go up and down. It actually states on the graph that there is a global seasonal cycle, and you can see it from that black squiggly line that goes along the black straight line. So that would suggest there is some seasonal fluctuation in the amount of carbon dioxide in the atmosphere. If you look carefully, you can see that generally the CO2 concentration peaks at the turn of the year. So there's a peak above the 2010 mark, there's a peak above the 2012 mark, for example, and the 2014. That would sort of suggest that CO2 concentrations are highest at the turn of the year. So of course that is winter, so that's sort of like December, January time. So you can say CO2 levels are highest in winter and they are generally lower in summer. The reasons for this is that there is more photosynthesis in summer. Obviously, the temperatures are warmer and there's more sunlight, so we know that both of those factors, temperature and sunlight, are limiting factors of photosynthesis. If there's more sunlight and it's warmer, then we're going to get more photosynthesis, and so plants will absorb more carbon dioxide from the atmosphere. Also, there's a lower demand for heating and electricity during the summer months. People don't need to heat their houses as much, and it's lighter days, so people don't need to turn on their lights as much. There's a little note on the side here that says, of course, that the seasons are different in the southern hemisphere, so they have the opposite, don't they, the winter to us. However, the important thing that you should know about that is the vast majority of the human population lives in the northern hemisphere. And also the vast majority of plants are also in the northern hemisphere. So whenever we look at CO2 trends, we'll always find that the levels are highest in the northern winter. So December, January, etc. And that is because most people live in the northern hemisphere and most plants are in the northern hemisphere. So that outweighs the effects of the southern hemisphere and their summer.